So I've started recording, and here we go. So operating systems. So is Tyler online to give the presentation? I suspect not, because I haven't seen him for a while.
So nothing after the spring break?
Yeah, I have not really heard from him since spring break.
Wow, that's sad.
Yeah. And then we have one of our students who went back to Korea. I've heard from him, but I don't know how active it is. I should check with Dr. Boss how we want to handle that. And so next is Ethan.
Yes, sir. Can you hear me?
Yes, I can hear you.
Awesome.
So go ahead and take over the screen and start it.
All right, can you guys see my slides?
Yep. Yes.
Yeah, I can see your screen.
Awesome. Cool. So my Devo for today is Lamentations 3:25 through 27 and 31 through 33. It says, "The Lord is good to those who wait for him, to the soul who seeks him. It is good that one should wait quietly for the salvation of the Lord. For the Lord will not cast off forever. But though he causes grief, he will have compassion according to the abundance of his steadfast love. For he does not afflict from his heart or grieve the children of men." So this verse in Lamentations obviously is talking about the steadfastness of God. In this time of uncertainties and trials for many, God is still for us. And we don't need to worry because we know that he's on our side. And this verse also kind of points out that patience is important through this trying time. But even though it may seem difficult, patience can come easy when you have hope for the future.
Yeah, I wouldn't say it's easy, but if you do give it to the Lord, it's easy, but
Yeah. Yep. So, all right. So I am presenting on the Plan 9 operating system from Bell Labs. So Bell Labs was created by Alexander Graham Bell. Little known fact. That's where the bell comes from. And while it may have been owned by many telephone companies, Bell Labs is known as the creators of Unix, as well as the creators of C, C++, and the S programming languages. Now Bell Labs is known as Nokia Bell Labs because it's owned by the Nokia phone company. So Plan 9 was created to solve most systems problems a little bit cleaner than normal. However, it has a very similar feel to Unix. Even though it is so similar, this is mostly due to coming from the same company. Most of the software was actually written for Plan 9. This includes the Windows system, compilers, the file system, and network services. So the things that were transferred over from Unix were actually updated to make Plan 9 a little bit better and to operate a little bit easier with Plan 9. So Plan 9 development was started in the late 1980s, and in 1992 they released the first edition and then 3 subsequent editions after that. The first edition was actually only made available to universities. The second cost $350 for public use. And then in the third, they made it open source. And the fourth, they released it under a free software license. So after this fourth edition, Plan 9 remained open source. And it is currently no longer maintained. I believe they stopped maintaining it in 2015. So one of the things that makes Plan 9 kind of unique is that everything is a file system. So all the processes can be manipulated like a directory with ordinary files in it. the processes cannot be copied or moved. However, they can be managed with file tools such as ls, cat, grep, cp, and rm. These are combined with the RC shell, which is the main shell in Plan 9, so that Plan 9 can be simple and easy to use, just like a file. Plan 9 was further simplified using UTF-8, which is a Unicode implementation. This allows backwards compatibility, which then allows for chaining of string data, as well as reliable processing of information. And then just another fun fact is that the original file server, Emil, is still in use today. Or Emily, I guess, is still in use today. So they kept the same one through the entire release process. So Plan 9 was eventually succeeded by Inferno, which works about the same way. It does have a few coding differences, but the main difference between Inferno and Plan 9 is that Inferno can run as a virtual machine or directly on hardware, whereas Plan 9 could only run on hardware when it was created. Are there any questions?
So what is the difference? Like, what was the benefit when he built this one?
When he built Plan 9 as opposed to Inferno, or
no, like for why? So I understood that he built a Unix, and why he wanted to create another operating system.
Yeah. So it was mainly to solve system problems. So making everything file system made everything a little bit easier and simplified it, I guess. And so you could just manipulate everything like it was a file using like the read, write, and execute, as well as the Unicode for it. And so in doing that, he created an operating system that was less complex, but looked very similar to Unix.
Yeah, that's right. That's my impression, is that he took the concept of everything as a file to even further extremes than Unix did, because Unix did the same thing, but it took it to a greater extreme. He's able to streamline the code to be a smaller operating system or a less complicated operating system. And you mentioned UTF-S. Wasn't UTF-8
Yes.
a result of this operating system? Was integrated into the operating system, was actually invented as part of this operating system, or is that not correct?
I don't know if it was invented as a result, but I think it was invented right around the same time as Plan 9 was, and so they integrated it right away.
Right.
But it's entirely possible that it could have been a result of Plan 9 as well.
Yeah. But definitely, it's integral to the implementation of the operating system is UTF-8. It's native. Yeah. Okay.
Wow. So Jessica says yes. So it is invented Unicode. That is pretty cool.
Chair, that was from the beginning of the presentation where I was saying, yes, I can see the PowerPoint.
Okay. Okay, I was thinking about, that would be super cool. So Unicode is now like a best thing that we have.
Yeah. So you can actually still download and use Plan 9 because of the open source. A couple people, I guess, have still been updating it. But I did not actually go and download it.
Yeah. I did have one of the students download it last year and played with it and said it was pretty fun. But you can look at it, you can see the era from which it was created, because the UI certainly doesn't reflect current trends.
Oh, yeah.
There won't be any like a software driver or anything, right? Like a special modern.
Unless you made it yourself.
So there's like no benefit of doing.
But you would just make it look like you're writing to a file for your new device, but you'd have to write it yourself.
Yeah.
So it's still a C++, right?
Yes.
Yeah.
And I bet there is like a compiler or anything, something like that. Does it use that apt-get thing, or does it have something different? Like when you're installing, files. I mean, like applications to the.
That's a good question. I'm not
Yeah, package
sure.
manager. Yeah, that's really interesting. So far, like a best. Like I'm interested in it much more.
Yeah.
Yeah, it's really interesting.
Yeah. So yeah, definitely a lot of good things have come out of Bell Labs.
Yeah. Nathan said that UTF-8 and Plan 9 were created by Ken Thompson and Rob Pike. And
Right.
so probably in he said they might not have been for each other, but they definitely were created around the same time and worked well together.
Yes. Well, good.
Oh, so like a one person that like shaped everything. That is crazy.
Yeah. Bell Labs, a lot of great technology has come from them, and not the least of which is transistors, right? So
Yeah.
modern electronics and stuff.
Nice. Well, thank you. That was really, really interesting.
Yes. Thank you very much. Great job. All right. Well, I'll go ahead and take over the screen. So next up is Ian with Puppy Linux. And after that, we have, get focus back, Cubes with John, and Android with Timothy. So nothing much new. Quiz on Chapter 8 due today. I actually did just send on an email message and announcement that the PowerPoint slides for Chapter 8 main memory are now online. I had a little glitch where I made a Canvas error and hadn't made it public so fully. I had made the actual slides and the page with the slides public, but the categories above it weren't selected as public. So those are now available. And Friday is a quiz on Chapter 9. Monday is the mass storage programming problem that Ochir mentioned, and was wondering if anyone started. I think they should be easy points because it's just simulating the behavior of some disk scheduling algorithms and just printing out the message of what tracks it goes to and such for particular patterns. So I think that should be a pretty straightforward programming assignment. And then Chapter 12 programming assignment exercise is extra credit points. So that's 10 extra credit points for those. So any questions about what we have going on here? So everything I think for the semester is laid out. If you have any questions, be sure to send me an email or call me or text me or whatever, and I'll try to answer them. But I think the semester is pretty much laid out now. We have 2 more weeks of classes and then the final. So, and I think you guys hopefully will enjoy the final. I give you some more information on that, but I have some good surprises for you guys on that. So any questions? All right. So on to file system interface, which is pretty straightforward thing that you've seen before. just going through here. Remember that there are different types of files. Remember that a source code file is basically contains the code for the software program, and the executable file is actually a series of code sections that the loader can bring into memory. And those are just two of the many types of files that exist, file types that exist, but ones that you should be intimately aware of, I'm sure, as computer science majors or related majors to computer science. And we talked about the attributes of a file. These are the properties that exist in the file that's stored as metadata for the file. Note that this information is not actually in the file themselves, but they are metadata associated with the file, as opposed to things that are in the file, like, for instance, the image resolution is actually a part of the file format. So they're not actually attributes of the file. They are actually information that's contained in the file, because for it to be a file attribute in general, they are unique. I mean, they're not unique to the specific file types. They are global across the different things, like the name, identifier, the type, protection status, time, date, etc., owner. Those are all general COSC files. So something like image resolution or nuances of PDF files, those kinds of things are part of the file format and not part of the attributes of a file. So we talked about the different file operations. You actually had a chance to write a quick and easy program. Hopefully it was easy for you guys, but it was pretty straightforward to actually use the file operations as part of a standard file access and see what kinds of operation the kernel did in order to support that. But there's all kinds of different file operations, and you are, I'm sure, quite familiar with that. We talked about file locking and different techniques that can be used for file locking. And this is so that files can be shared by multiple users. We also talked about file extensions, which are associated with the types. The Mac actually had something called a resource file, but a resource fork, I believe, and they've kind of strayed away from that. But certainly in Windows, it's very common to have an extension associated with each of the types. And notice the executable file is an exe file, and .com is another one, and then a bin file is scripts and things like that. Bash files are .bat and .sh and things like that. So just remember that there are various extensions associated with different file types, and for instance, .exe is executable. So we talked about file structure, how files are organized, that depending on what type they are, and it's a combination of the operating system and the program, which decides the formatting that is being used. And certainly we have standard conventions of what files look like PDFs and text files and things like that. One thing to note, actually, that's of note, and I think a lot of you may have discovered that, in Windows, a text file generally uses as the end of a line a carriage return and a line feed, whereas in Linux it is only the line. It is only the line feed, I believe. Is it character return or line feed? It's only one of them. It's escaping me right at the time. I think it's a line feed, but it's only one of the characters. So there is a mismatch of a text file between Windows and Linux and Unix, but most of your tools handle that gracefully, knowing the difference, and will handle either type. So we have access methods. Sequential access is just reading them sequentially through the list of the file. It is the simplest access method for accessing file because it's just going read next, write next, read next or write next, reset, which is go back to the beginning, or rewrite, no read after the last write. So you're just walking through the file in a sequential manner. By far the simplest technique, but also not quite as capable in many regards. So the other is direct access, which allows reading and writing records in no particular order. You can skip and read logical record N, write logical record N, position to N, so and then read next, because it does have the concept of reading in order, but you can jump around through the file. So this is a lot easier technique. I mean, a lot more capable technique in that you can read and write files in any given order. But then, of course, it has performance issues based on that capability, either pros and cons, depending on what you're trying to do. It can even improve performance or decrease performance, depending on what you're trying to do and what your application is trying to achieve. But it allows you to directly access a particular block. And you would see this in a lot of the hierarchical databases. Some of the older style databases will use direct access to jump around in the file. And notice that the N is a relative block, so you're looking at relative locations in the file to position and to read and write. The other methods can be built on top of these base methods. Generally, they involve some type of index into the file. So we can see here that we have an index file on the left here with the data, for instance, last name, and then it has a pointer or a reference to the location in the actual file. The index is used for fast determination of location. So again, very similar to the way memory is mapped. You are doing the same thing with the file access. IBM was famous for their ISAM method, which is index sequential access method. And those are some of the details. And I mentioned before that this random access through in particular through an ISAM system was a common technique for database implementations. And then VMS is another operating system that provides index and relative files. So again, nothing too new for you folks, but generally the files are located in a directory structure. And so you have a collection of nodes that have information about the files. That's the metadata attributes that I was talking about. And this metadata then references the files on disk. So it is through a directory structure that we access. This is by far the most common way when associated with a tree structure, and we'll get into that later. But again, I think the directory tree structure will not be new to you, as by this time you probably have great experience working with file systems and directory structures. So there are many different types of file systems. Solaris has TMPFS, and all these listed down here below. Remember, we saw ZFS in relationship to large multi-node redundant type operating systems. And so there are a lot of different operating systems, and we know that Linux has actually had lots of different operating systems where there's been attempts to increase the performance and to handle failure cases as well. I have definitely written programs to work around some deficiencies in different file systems, and the choosing for your application of the appropriate file system type can be very important in the development of applications that you may need to consider. And in particular, Linux has many different versions of file systems that you can utilize, and you may sometimes sometime in your career come across the circumstance where you'll have to do some research on different file systems and see if you can match it up well with your application. You know, there are certainly default file systems that come right out of the box, and you may not need to do it, but if you're looking for high performance or high reliability, you may have to look at that. So operations performed in a file, you can search for the file, create the file, delete, list a directory, rename a file, or transverse the file system, which is doing a change directory and going for different places in the file system, the directory structure. Generally, there is a directory that's the current working directory, and that is if you do a relative path, and we'll talk about this more, it's relative to your current working directory. So if you don't give any full-blown directory information, it's the default directory is where it'll look for the file. So the text goes in great detail, or not great detail, but talks a little bit about single-level directories, two-level directories, and tree structure directories. Key thing, you can take a look at it, but the key thing I want you to remember here is tree structure directories are by far the dominant directory structure that's used. You can see here we have the root, it has spell, bin, and programs, and then you traverse down the tree to subdirectories, and then ultimately to the round dots, which are the individual files. So that's the most common structure, is the tree structure directory. So please remember that. So tree structure directories, I talked about absolute and relative path names. So the relative path name is relative to the current working directory, the current directory. CWD is a common abbreviation for current working directory, and that will be relative to where that directory is. Absolute is actually a directory that's specified from the root directory or the main root of the file system. And so it's basically a completely specified, or sometimes you'll hear canonical, which uses the fact that it's absolute straight from the root, but it also talks about as it being the shortest and most unique. And you'll see that in some file systems, there's actually multiple ways to specify the same file, and that's where you get into canonical. But that's something that you probably won't have to deal too much with, I'm hoping. But if you ever come across searching for directories and have problems, you might want to look up what exactly we're talking about when we talk about the canonical name for a file, which is the path. So again, the absolute is from the root. So if we look at directory structures, it will be a name that starts with a / for Linux and Unix and various operating systems like that, or a backslash in Windows, which is the slash going from high to low as you go from left to right. That's the backslash, and that's what Windows uses. And so those will be the ones that are absolute paths that start with a slash. If it doesn't start with a slash, that means it is relative. It's a relative directory. Typically, like I said, relative to the current working directory. You can do various operations on it, remove, and then we'll talk about making subdirectories and such like that. You have all, I'm sure, seen that. So here we have another scheme, which is acyclic graph directory. And this in particular, you can see that there can be more than one path to get to the same file. The round circle is a file, and you can see that there can be multiple paths to the file. For instance, if you go to DICT and then to count, you can get to a file, or you could also get to it from spell and then count and then get to the file as well. So you can see here that there are two different names or aliases available for a lot of these files. And we have here that you could have a dangling pointer. So you have DICT deletes the list directory, and we could have a dangling pointer to something that doesn't exist. And so the solution is to have a back pointer so we can delete all the pointers associated with it. This is standard data structures stuff that you've discussed in terms of different tree structures and lists and pointer types and that kinds of operations. So that's what we're talking about here. We're just looking at different data structures, which the directory structure is a data structure, and the links between them and how to resolve the links. Again, these are not common. Usually we have the tree structure is the more common. Then the text talks about how do we guarantee that there's no cycle, that you don't get in a redundant situation where you just keep cycling forever. We talked about garbage collection when you remove it, getting rid of all the possible links and removing it. Again, not as common as tree directory structures. File system mounting. So file system must be mounted before it can be accessed. Generally, this is part of the startup procedures with most operating systems to mount the disk you need. But especially in Linux and Unix, you will see mounting and unmounting of files. I guess less so with the GUIs, the GUI front ends for Linux and Unix operating systems, where a lot of times that information is a little bit hidden from you because you click on it and it will automatically mount things for you like a CD. But typical in certainly in Linux and Unix is the concept of having to mount the file system at a mount point. And so you mount that file system, which is usually associated with the device, at a particular point, and then that gets tied in or hung on to the file system at a particular mount point. So you can see, and I think there was a presentation on this. Let's see, whose presentation was it? Right now it's escape. Oh. Anyway, it talked about the standard directories, and so we had that /dev is where hard disks typically get mounted, and so you'll see something like /dev/sda1, but then we also have other directories that are where optical disks and CDs and removable media get mounted, and USB sticks. So those are also possible as well. So when programming for Linux and Unix, you may have to deal with mounting file systems or developing applications and systems for them. File sharing, there's generally lots of ways to share files across multiple users. And then when sharing is involved, usually there's protection schemes. We looked at in Unix and Linux, the read, write, execute, and delete permissions and owners and groups. So that would be a common, those are common protection schemes for protecting access to files or controlling access to files. And a distributed file system, we talked about sharing across the network. NFS is a common method for file sharing. So if you've heard about SMB Samba, that is actually the Linux version of accessing the network file system. And so again, all these different standards exist for accessing different type of network file systems. In multi-user systems, generally, the user is identified in terms of protection schemes or access to files get with a user ID and a group ID. So you have your unique identifier associated with each user, allowing permissions, or they can belong to various groups, permitting them to get group access based on the group that they belong to a file. So we have an owner of a file and a group. We have an owner associated with the file and directory, and we have a group associated with the file and directory. So those are things that you should keep in mind, is that owner and group is the dominant methods for controlling access to files in a file sharing environment. There's various different failure modes. So for corruption of the directory structure or the file or the metadata, which is the attributes of the file, can get corrupted. And there's all kinds of techniques to try to mitigate those types of failures and recover from them. Again, talked about, there are some protocols. The text talks about protocols. I'm not going to go into that in too much detail, or any detail really, other than mentioning that there's stateless protocols. NFS version 3 uses stateless protocols, but there's various protocols involved with recovery. So already talked pretty much about protection. This is just a more detailed slide of the aspects of protection that are involved, and there actually is a whole chapter on protection in the operating system textbook and generally taught in this class. I think I probably will skip the protection directory, but we'll see how far we get. We have access lists and groups as a protection mechanism. And we talked about the read, write, execute bits and the use of octal in Linux to specify those. So 111 in octal is 7, and so that's complete access, read, write, and execute. Or we talked about read and execute is 6. It's 110, which is 6 in octal. And so we actually did come across that in our quiz on Linux commands. So again, the most common technique is a unique identifier associated with the user and putting them in groups. So this is just what the top one is, what window access looks like in Windows. This top picture in the top right hand corner is Windows, and then down below on the lower left is Unix directory structure listing, which you see here and have become familiar with in this class. All right, so any questions on that material or about the class in general? So trying to decide whether I'm gonna move on here. So let's go ahead and call that quits for today. Unless you have any questions, you're certainly dismissed. And so any questions? Okay, I'm going to go ahead and stop recording now. And